Hi students, now we will go to another topic, complex functions. Complex functions. So we already know about the functions in real space. So functions we generally represent it like this. Y is equal to f of x. Okay, so y is equal to f of x. That is, y is a function of x. That means how we represent it. This is the case of real. We are talking about the real first, then we will go to complex. So this actually, what does it mean? It means for each x value you have a certain value. Okay, so you can map it like this. So this is your x. Okay, then for each x you have a y. So that means for each x value you have a certain y value like this. So if you have another x, you have another y. So this we call it, this is your domain, and this is called the range. Range means for a particular value of x in the domain, you have a particular value of y. Okay, so this is the situation in your real case, like y is equal to f of x. You may have y is equal to x squared. Then, how do we plot it? We can plot it. This is your x and this is your y. Okay, y or f of x. Okay, then y is equal to x squared. Then what would be, how would be the what is called the plot that you are getting? So here this is somewhat like for each x values. That means when x equal to 0, y equal to 0. X equal to 1, y is equal to 1. X equal to 2, then y is equal to 4. Like that. So whether it is negative or positive, you will get the same. Okay. So this will be a somewhat like a harmonic function. If y is equal to here is x, then this will be somewhat like so this is your x, and this is your y, then you will get something like this. So this is 1 and it increases exponentially. So this is a situation in the case of real numbers and real functions. So this is the real functions. Now we will go to our complex. The complex functions, it is not simply like this because it has dependence on both x and y. Okay, so in complex, the case of complex, how the variables, we already know that is equal to x plus y. Okay, so this you can represent it in a complex plane. So this is your real, and this is simply writing x because this is a real part and this is the imaginary part. Okay, now how to get it? So you get it like you can take different values of your z depending upon the x and y value. So this domain, this is the domain for your z values. Now, when it comes as a function, then what would be the situation? So here you have your complex functions comes like z is equal to u plus iv, and u is a function of x comma y and v is a function of x comma y. So for each z you have some particular set of u and v. So here I am plotting u on the x the real axis and v on the imaginary axis, and here you will get something on the this plane. So this plane we call it as a z plane. Z plane, and this we call it as a w plane or the function plane. So for each z here, that is z is equal to x plus iy format. For each x and y, you have a particular u v on this w plane. Okay, so actually it becomes like z is equal to x plus z is equal to x plus iy. So this is in z plane, or you can say this is z. Now in the w plane we have w is equal to u plus iv, u plus iv, or here this u is a function of x comma y plus I will be of x comma y. So here for each z you have a particular w, and this z is a function of x and y, but w is a function of u and v, but u is a function of x and y, and v is also a function of x and y. So for each x comma y values on this z plane, you have a corresponding what is called a w on the w plane. Okay, so this is the way how it is. We will take a few examples and you will understand it in a more correct way. Okay, so we will take a few examples. Z square. So this is a function, you have to make it is in terms of u and v. So we know z is equal to x plus iy. So now what about this? F of z is equal to x plus iy all square. That means what about this? This you will get x square plus 2 into I xy plus I y all square, that will be minus y square, because I into I become minus 1 and y minus 1. So you just take the real part and imaginary part separately. So you will get x square minus y square plus I into 2xy. So here this is your u and this is your v. So you can write u plus iv. Okay. So this is a way how to get a complex function. Okay. Now we will go to another example. We can do it for I'll take another example. Z minus 2 real z. What about this? So here you know z is equal to x plus iy. And what about the real z? Real z is, because z is equal to x plus iy, so real z is nothing but x, your real part. So minus x. So you are getting I1. So this is the result. Now what about u? U of xy is equal to 0 because it doesn't carry any real part. And v of xy is equal to 1. Understand? Okay. So you can write your f of z is equal to I. So it becomes this a function. So this is a complex function. Now you may have something like, I will just give you some other examples like f of z is equal to mod z square minus imaginary part of z. So this you want z over I might go z plus I. What is this? What is mod z? Mod z square. I already told your z is equal to x plus I1. So what is mod z? Mod z is equal to x square plus y square all raised to half. So mod z square is nothing but x square plus y square. Is it? Now imaginary part of z plus I. Z plus I is z plus I is equal to x plus iy plus I. So what about the this is x plus I into y plus 1. What about the imaginary part of z? Imaginary part of z is I into y plus 1. So you write this is equal to x square plus y square minus I y plus 1. Okay. Now you get the what we call, actually you need imaginary part of z plus I. So you have to take only y plus 1 only, because you don't have to carry. That is the imaginary part. Actually in a complex number, when you write a complex number, z is equal to a plus ib. So this is the real part and this is the imaginary part. Okay. So in this imaginary part, this will give you the what is called the coefficient of the imaginary part, and here you are asked to write that one only, imaginary part of z plus I. So we will write y plus 1 only. Now what about u? U of xy is equal to x square plus y square minus 1 plus y minus 1. Y minus 1. And b of xy is equal to 0. So your f of z, the function of z, is equal to x square plus y square minus y plus 1. It is only the what is called the real part. The real variable remains, the imaginary variable vanished. Okay. Now we will go for the mapping, complex mapping. Like in the real mapping, we got for each x value you have a corresponding y value in the range. In the domain you have a particular, for a particular x value in the domain you have a y value in the range. Okay, that range. Okay. Now similarly, for example, you are considering a force that is equal to z square. That is our first example. Here you have both u and v. So that means your u of x comma y was equal to I think this your x square minus y square, and v of x comma y was equal to what is called 2xy, because you don't have to write I into 2xy, because we write f of z is equal to u plus iv. So this v only coming to 1. Understand? Now how to plot it in the how to make the corresponding mapping from z plane to w plane, that we have to see. So for doing that, I will just draw my z plane. This is my z plane, and this is my w plane. Okay. Now what I have to look, because in the z plane you have x and y, that is the real axis and imaginary axis, and on the w plane you have v and u and v. On the real axis you have u, and on the imaginary axis you have a v. Here this has so many values, okay, that you can take depending upon the value of x and y. So we will look at z is equal to x plus iy. This is you want to make the points or locus of points having z is equal to what? X plus iy. So basically when you do it, you have infinite number of points depending upon the x and y. What I am going to do is I will just make x as a constant. That means I am taking x equal to 1. So if I take x equal to 1, then your z is become 1 plus iy. So now I have to look all the locus of points that give you z is equal to 1 plus y. Then I will look at the corresponding v. Okay, that is more easier to deal, because otherwise you have plenty of points. So here I am just taking z is equal to 1 plus iy. Now what about this? The z plane, you can plot it like, because z is equal to 1 plus iy, because my real part is 1, the point 1, and I can take infinite number of y values from 0 to all the values plus or minus. So this will be, I will just a different color. This will be somewhat like this. This is the plot in my z plane, and now I have to look at the corresponding on the w plane. The w plane, now what is the situation? I already fixed my x value. So now my u becomes u is equal to 1 minus y square, and v becomes 2 1, because I already taken x equal to 1. Okay. Now how to draw it? That is my question, because u is equal to 1 minus y square, then v is equal to 2y. I will just make the solution, that is I have to get u in terms of v, then only I can make a draw in this w plane, because my axes are u and v. So I will just substitute it. I am just doing it here because u is equal to 1 minus y square and v is equal to 2y. Now what about y? y is equal to v by 2. So I just substitute it back. Then u becomes u is equal to 1 minus v square by 4. Isn't it? Okay, v square by 4. Now what about this? This is an equation for what? This is equation for parabola, and important thing is your what is called the vertex. It is located at 1, and this is minus v square by 4, so it is open towards the negative real side. Okay, so this will be the vertex is located at 1, and it will be something like this. So this is the corresponding mapping. For each y mapping you will get u and v. So in this fashion, this is called complex mapping. Complex mapping. Okay. So I will just wind up it here, and some other concept we will do in the next video.